Hello everyone, and welcome to class P17. That's GMAW issues and resolutions specific to wire feed electrode surfaces. Now, the first thing I want to talk about is copper coating. A copper-coated wire, and I'd like to back up just a moment if I could, and let's understand what the copper's on there for. Always keep in mind that the copper has absolutely nothing to do with the conductivity of the wire, making it any better or anything in that way. In fact, many would argue that one of the best wires in the world are copper-free, where they use a different type of post finish that we've talked about in other classes. I'll get into post finishes a little bit later. But you remember what the copper does. The copper actually goes in and it works like a body filler. It actually goes into all the little crevices that are made during the drawing of the standard wire, and it fills them in. And then there's one more drawing of the wire that puts it exactly on size. Now, I just want you to remember that all this copper you see, it's not plated. If you took a piece, and here's a good test for you to do. If you took a piece, you took it out outside, about a foot long, and just throw it somewhere out of the way so it can get wet and dry and whatever. Come back in a week and you'll notice that it's very rusty. This roll that you were looking at right here, all this wire, this was on the side of a reel, a large reel, and some water had blown in from outside and touched the surface. Now, the complaint from the customer was that this particular wire, the plating must be wrong because it's rusting. But then I took the time to teach them that every single one they're ever going to touch, it's not plated. What it's actually done, it's like fish scales if you looked at it really closely. When they draw it the very last time, they actually take a little bit of copper that's stuck to the surface and they draw it through, which gives us a smooth surface, which helps a lot with contact tip life. The wires that actually have no copper coating on them, they have to be super critical on that surface finish to get that to work, or it just starts chewing up contact tips like crazy. Now, this copper just sits on the surface. And as I say, it's just like it just goes on. It actually gets drawn. And the easiest way to try to figure out what it looks like, if you're trying to get a picture in your mind, is it look like fish scales. Fish scales all run one direction, and that's because that's the way it's drawn. Now, occasionally you'll get a situation where if you look at this wire feeder here, this particular wire feeder has a bunch of copper flakes in it. Now, these are dry flakes. Don't get confused between dry flakes and wet flakes. Wet flakes is usually just the coating on the outside, which could be a mineral or it could be a wax, has built up a little bit. That's different from loose flakes. This is proper flaking where the wire is where this copper coating is actually coming off. Sometimes the wire actually gets reversed because it's made with fish scales, like not fish scales exactly, but with this fish scale effect. You end up getting, if it's reversed, you end up getting a point where you're tearing off those little scales as it's going backwards, because you have to remember which way to draw the wire. Sometimes the plants mess up a little bit, and when they're going back and forth, loading and unloading wire off the big reels onto the smaller reels, onto the spools, onto even 1 pound spools. So they've got to keep the direction correct. Sometimes they mess up, and this is a common factor. So you're rarely ever going to see anything like this, what you're seeing here in this picture. But when you do, immediately go right to your drum and see if something's going on in there. You won't really be able to tell. I would move it to another line, that drum, and put it on there and see if the same thing happens. If this is what the problem is, that's exactly what it'll do. It'll do exactly the same thing. It won't make any difference where you put it. Here's a close-up shot. I've got a few of these that I'm going to show you through the various courses. But just so you can see that the copper is literally compressed. You can't even see a trace of steel in this particular little lamination here. And these are the imperfections that you commonly see. Now, this is a very poor quality wire. I'm not saying any names or anything like that, but it has a lot of problems. And what happens is the post finish that they put on, that I talk about, this stuff, and the post finish is this coating that's on the outside. Sometimes it's just a residual from the manufacturing process. Sometimes it's actually put on there deliberate. But when you do a post finish, it's supposed to help with your conductivity. It's supposed to help with your movements through the lines. It's not supposed to build up on anything to create any type of extra drag and build up on the wires. But one thing it does do is when you have these surface imperfections in the wire, it actually sits in there and waits. And when it gets to the conductivity phase where it's actually sliding through a contact tip, you get little explosions from these indentations that are full of this post finish. Now, contact tip. 2 contact tips, same gun, same wire, same diffuser, same program, same contact tip, same time. Why does one look like that and why does one look like the other? It was the perfect example, and I find these pictures over the years, but this was a perfect example of somebody that didn't tighten up the contact tip enough. When you don't tighten up the contact tip, the cooling of it can't work properly. The diffuser can't do one of its main jobs, and that's to make sure you've got good electrical connection and you have a good and a good seal. So when you have this one, why you got all this extra buildup on it is because the copper, this is very important now, the copper was getting very close to its threshold of melting. When copper gets to its threshold of melting, this is the result. Spatter balls can stick to it because the spatter balls are hot and they push it over the edge to the point where it's actually fused to it and literally welded to it. You would have to take something, and that looks like it'll pop off there. No, it's really literally welded right on. So it's fused into the surface. But that's why you only see it up here at the beginning, because the plasma was so close to it, it had it so hot. And in this particular case, it was a micro arcing condition that we knew how to fix because it was in the wire handling. And as soon as we fixed it and I made sure the contact tip was tight, we didn't have this problem anymore. Now this is typical, and I could probably step back here for a minute and make a point. One of my favorite places to go as soon as I walk into a plant for the very first time is to head for the scrap copper bin. I like to look at things like this. I like to look at contact tips that are dead because contact tips, diffusers, nozzles, they tell me the story about what's going on in your plant. In this particular case, notice the condition of the wire. Notice that the wire has fused itself and it's done a condition called stubbing. This turned out to be and is a common problem. When the wire comes out, the robot goes into its position where it's supposed to go, and the wire is sticking out so far that the wire makes contact with the plate. It is very important that the wire not be grounded out, not be stuck on a surface when that contactor pulls in and it says to go ahead and weld, because that surge will cause these to spike and you'll blow that little piece off the end, it'll go flying, and your contact tip's going to sit there like this. The important thing to note when this happens, when you know that this is it, you need to look at the surface right where the contact tip sent the wire. That spot on that on the surface. When you look at that, you'll see that it'll almost leave like a little fish hook of material where the wire came out a little bit and then it ended up getting just bounced off, and then we just fused the contact tip to the inside. Now, one of the best wires out there for operation, and I would tell anybody, is a Lincoln product. Lincoln L50 and L56 are exceptional. The thing that makes them exceptional is they actually have a wax-based post finish. Now, wax-based post finish, their recipe is very good. I don't think there's anything that can compare with it that I know of, and I don't know anybody else that actually applies a post finish like this. But see the green, the waxy substance, that's actually what they put on their wire. There's certain times of the year, it seems to be in the summertime when it's much hotter out, we would see this buildup actually happening in the back of the contact tip or on the drive rolls. I have a few more pictures like this, but it's something that we deal with if it starts getting too thick, we have to do something about it. And it will build up inside your liners and that. These, especially anybody running a Lincoln product, these Lincoln products, you need to make sure you do tensile tests on the wire, because this wax does work very well for the conductivity, for the smoothness of transition of power. All those things work super. What it does do, though, is it builds up, and it'll add a little extra drag where you don't, at times, especially when you don't want it. Here's another one that was similar. You can see a little bit of the green. It was also a Lincoln product. So this wax base post finish comes off, and it could be, like I said, a wax base or a mineral post finish. Now this was reported to me as a rough weld, and they said to come and have a look at it, and they were all over this being a problem with the wire. They wanted the drum of wire exchanged. So I talked to the people that sold them the wire, and they said they were going to get one, but they said that it had to be this particular one. As I went through it, I came across this wire, and it just so happens, and I've put this picture in this presentation because that was the original thing. They thought for sure the wire had a problem, but every time they tried it cold, it seemed to work okay. But as soon as it got hot, of course, it fell off again, and it was something else. It's always good to have a look at your entire system. I don't know what plants have FLIR cameras, forward-looking infrared, that can actually see temperatures, but it's one of the most efficient things and one of the greatest things you could possibly use to look after some of your troubleshooting. Starts. When you start a weld, these finishes and what's inside this wire, we all have S3s and S6s, and these are very common, ER70 S6, ER70 S3. S6 has more silicate. It flows a little bit better, but it has one challenge with it. It gets a lot of glass on top of the weld, and I think everybody's seen that silicate that builds up on top of the weld. S3 has less. It's not as bad. Now, it's not the greatest picture in the world, but this is a ball that was finished up on the end of a wire during a termination. And it was giving us a ball almost every time. But when it was trying to restart, it wouldn't restart. It would give us all kinds of problems. It would create that, leave that little fish hook and create that problem right at the beginning where it starts to sputter. I want you to just see right here. I'm actually circling an area right now. There was a huge silicon island on this one, and that silicon island's made out of glass. That's what silicon is. And the glass was actually insulating the start of the electrode. So it actually had to come down, hit the surface, try to scratch some of this stuff off of it, some of this silicon off of it, scratch it off, and then it would actually start doing the welding. So silicon is one of your other challenges. Now here's a picture of a diffuser. This was a standard Tergascus diffuser, and there was something else going on, and I'm putting this out there during this particular part of the course, because it's related again to why did they call me? Because the wire is not running right. You have to look at all these different parts, and I could focus on this one for a second only by saying the outside of this gun, this diffuser, when it went up, the outside of the gun was actually touching the aluminum. Now, that shouldn't have been a big problem if the aluminum on the outside of the gun were insulated as it should be. But in this particular case, this was very much a brand name item. In this particular case, it was actually arcing on the diffuser, between the diffuser and the ring where the outside cover on the gooseneck finished up. Pay attention to stuff like this. Look for places where arcing is happening that it should not be. And just one last picture of one company that I set up years ago. And that is actually a piece of Teflon. It does not require a reamer or anything. And it's so flexible that you could go ahead and bump into things with it if you wanted to. I just put it on there as an interesting discussion because there are other ways of doing things. That one, by the way, is probably about 4 or 5 days old. And commonly they would take them and actually, which I never thought of, they took them and flipped them around and used them the other way for a while, and they cost about $4 a piece. That's all for this part of the presentation now, folks. Thank you very much.